Suppose we assume the supply and demand for one-bedroom apartments in Campus Town are the following, where QD and QS are the quantity of one-bedroom apartments demanded and supplied respectively in thousands, and P is the price of one-bedroom apartments. We can use these equations to draw the demand and supply curve for apartments in a diagram with the quantity of one-bedroom apartments along the horizontal axis and the price of one-bedroom apartments in the vertical axis. Can we use this more formal model to answer our original question? Should we increase or decrease the rent you charge for one-bedroom apartments due to a decrease in demand? And to make things more concrete, let's say that we knew the decline in enrollment will be about 5,000 students. Let's answer the question again, this time applying our comparative statistics method to the supply and demand model we just introduced. Again, step 1 is going to be describing an initial state in the market. Now notice that this step now involves setting up the problem in math terms, either in equation or in a diagram, for the initial state, namely the market equilibrium. In the supply and demand diagram, equilibrium means the intersection point of the supply and demand diagram. Let's call that A. In algebra, equilibrium in a market means quantity demanded is equal to quantity supply. It's another equation. In the math model, that means adding the equation QD equals QS. Notice that since we now have 3 equations and 3 unknown, we can solve the model for one of the unknowns, in this case, the price. In our case, the rent for apartments is going to be $500. So we can now also write that value in our diagram. In step 2, we're going to introduce the change in the market and evaluate how the change will change the initial state. This step now involves finding how the model changes as a result of the market change. In the diagram, a reduction in demand means a shift in the demand curve to the left to a new equilibrium point. Let's call that B. In the equations, a 5,000 change will be a change in the intercept of the demand equation from 25,000 to 20,000. And then we can solve the system again for the new equilibrium value. So step 3, this is a step that we're going to now compare the answer in our model with the previous one. So it is now clear from our diagram that the market price for apartments is definitely going to fall. And our system of equations tells us exactly the same thing, and it actually tells us the value of that decrease, which is $100.